Welcome to The Explainer. So today we're going to dig into something fascinating, how incredibly complex things, like a massive traffic jam or even a stock market crash, can pop up from a few super simple rules that individuals follow. It's a huge idea, and the answer is pretty surprising.
All right, to really get this, let's start with a little puzzle. It all kicks off with a simple question about how groups behave, and it shows us something kind of mind-blowing about how all sorts of systems actually work, from crowds of people to financial markets. Okay, picture this. You're in a room with, say, 30 people, and I'm going to give you just two very simple rules to follow. Rule number 1, randomly pick two other people in the room. We'll just call them person A and person B. Now for the second rule, and this is the only other thing you have to do, just move so you're always standing right between person A and person B. You're basically their protector.
So what happens? Well, at first, it's just total chaos, right? People are just kind of milling about, moving around, seemingly at random. But after just a few moments of this, something absolutely remarkable happens.
The whole room just implodes on itself. Everyone crushes together into this tight little knot, usually right in the center. Now think about that. No one planned this. Nobody was in charge. Nobody said, hey, let's all huddle up. And yet this perfectly coherent group behavior just appeared out of those simple individual rules. So how in the world do we explain that?
Well, the answer is a really powerful simulation method that was designed for exactly this kind of thing. It's called agent-based modeling, or ABM for short. The whole idea is to simulate a system not by looking at the whole thing at once, but by modeling the individual agents inside it, like people, or animals, or cars, each one just following its own set of simple rules.
And you got to understand, this is a totally different way of thinking. Traditional modeling is top-down. It tries to get the big picture by looking at the whole system, like a city's overall infection rate. But ABM, it flips that completely on its head. It's bottom-up. It starts with each individual person and then just watches the big pattern grow out of all their little interactions.
This really gets at that famous quote from the statistician George Box, all models are wrong, but some are useful. And agent-based models are so useful precisely because they don't pretend they can capture all of reality in one giant perfect equation. Instead, they let us see the magic that happens when all those individuals start interacting with each other.
And there's actually a word for this magic. It's called emergence. An emergent phenomenon is a pattern that pops up from the interactions of the agents, but it's not something you'd find in any single agent. It's that classic idea, the whole is way more than the sum of its parts. And that's why these patterns are often so surprising and almost impossible to predict. So let's bring it back to our game for a second. That tight cluster that formed, that wasn't in the rules. Nobody was told, form a cluster. That behavior emerged from everyone just trying to follow their own simple little rule. And that, right there, that's the power of emergence.
And listen, this is not just some fun thought experiment. This is used to solve huge real-world problems. Take theme parks, for instance. They use ABM to tackle their biggest headache, those lines we all hate. By simulating thousands of individual visitors, each with their own plans for the day, they can test out new park layouts and figure out how to slash those wait times, all without having to move a single real-world bench.
Or how about something with even higher stakes, like the stock market? Let's say regulators want to make one tiny little rule change. Well, in a system that complex, that one small tweak could accidentally send the whole market into a nosedive. ABM lets them create a virtual market with millions of simulated traders to see what happens, finding those disastrous unintended consequences before they risk it with our actual money.
And of course, this one's pretty familiar to all of us now. It's absolutely critical for modeling how diseases spread. Instead of just working with an abstract infection rate for a whole city, ABM simulates the virus moving from person to person through all of our daily routines and interactions. It gives a much clearer, much more realistic picture of how an outbreak actually unfolds.
So you see, what we're really talking about here is more than just a fancy computer model. It's a whole new way of looking at the world. Researchers Epstein and Axtell put it perfectly. They said, this new approach might change what we even mean when we ask someone to explain something.
I mean, think about how profound that idea is. Maybe the best way to really explain a complex pattern, whether it's a traffic jam or a new trend, isn't just to describe it from the outside, but to actually grow it from the ground up, starting with simple individuals. It really makes you wonder, right? What's that one complex thing in your world that you'd love to grow from the bottom up, just to finally see how it really works?